So blockchain privacy, add-on or mixer privacy. So remember our taxonomy, we have add-on mixer, add-ons or mixer for privacy or native privacy in the blockchain. So now let's look at just a few examples of potential mixers. So CoinJoin is a fairly old and famous approach where if you have two Bitcoin transactions here, again, input, output, two transactions, right? 1, 2. Why don't you merge them into one big transaction? If you do that, it's harder to know whether these 5 Bitcoins here are sent here, here, or here. Basically, the anonymity set size of from where to where money is spent is bigger. So the advantage here is kind of hides the originator of a transaction, or it makes it harder to infer, rather. It's not properly hiding it, the originator of a transaction. So the drawback of this approach is that you need some kind of a trusted third party to merge these transactions, right? Who does this merging? There's no spontaneous mixing. You can't just like do it on your own. You have to work with somebody. It also doesn't hide the amounts, right? You can see here, well, there's an incoming 5 Bitcoins. So where do you think it's most likely that these 5 Bitcoins went? Well, to ETH, right? These are 4 Bitcoins. Here, this input could not spend 4 Bitcoins alone to ETH. It needs the help of the other input. So the anonymity set size is still relatively small. By small, I mean it's restricted to the number of participants that you manage to mix your transactions with. Another approach, another add-on privacy solution is something like Tornado Cash, which is deployed on the Ethereum mainnet and is quite heavily used at the moment. It's basically an idea that originated in Miximus or Micromix. So the idea is that you have a pool of coins, and the depositors, they always send like 1 coin into this pool, right? So it's never like 1.5 or any other denomination. It's always a fixed coin denomination, and you also can only withdraw a fixed coin denomination. Now, in order to withdraw, you need to provide the smart contract of this pool. You need to provide a zero knowledge proof that you own 1 coin in the pool. And if the smart contract thinks that your zero knowledge proof is right, then you can withdraw a coin to a new address. So here we have 2 deposits from address Alice and address Bob, and we have 2 withdrawals. So we don't know whether Alice withdrew to address Eve or to address Frank, right? So you just don't know. So what's important, however, for practical purposes is that the transaction costs, they must be paid from a neutral or new address to avoid linkability. Right? So this transaction costs on Ethereum, for example, it costs gas. So this needs to be paid in Ether. So where do you get this from, right? So one practical approach would be to use so-called relayers that you can find on the Tornado Cash website. So a relayer basically receives. So he will like receive here, for example, 0.1 Ether, and you basically provide the zero knowledge proof to the relayer, and the relayer then creates a transaction and pays for the gas. So it seems like the relayer is the one sending this transaction, because the gas or the ether is sent from the relayer, but in the end the ether here is paid to the ether is paid to the relayer, so that plus maybe some margin, so that the relayer can continue its operations. So that's a particular kind of fix to this gas issue, and this is actually like the gas issue is an issue that many researchers don't look into, and I think for practical purpose that's really important, especially in mixers. Good. So we have this pool. So what's the advantages and disadvantages, right? So, well, it does hide the origin, or it does conceal the originator of a transaction, at least in some kind of an anonymity set, right? Like hiding is always like a bit hard of a word. There's an anonymity set. And the set size depends on the number of depositors that came into this pool. And as long as not everybody goes out of the pool, the anonymity set size technically just grows, right? When everybody goes out, the anonymity set size goes back to 0. So ideally, you never want the anonymity set size to go back to 0. So what's great about this kind of protocol is there's no coordination needed among the users. They don't have to talk to each other. They don't have to synchronize. They can just perform. This this kind of mixing in this pool. They can stay as long as they want in the pool. They can go out when they want, etc. So the drawback is that you need some fresh coins to withdraw or a third-party relayer. So if you use the relayer, then you should use like VPN or Tor, right, to protect yourself. Clear the browser cache. Then you should probably not use Infura, because Infura might also leak your identity. So there are a lot of things to be thinking about when trying to act in a privacy-preserving manner, or to use blockchain protocols in a privacy-preserving manner. One bigger bottleneck is that you cannot, so once you have a coin here in the pool, right, you cannot send this one coin to another user. You need to first withdraw it, and then you can send it to another user. And ideally you would want to transfer this coin to another user, right? So that's one bottleneck, and the other one is the fixed coin denomination, which is okay, but Tornado Cash, for example, has like a pool of 1, 10, and 100 Ether. And if you want to send 50 Ether, then, well, you have to, if you want to mix 50 Ether, you have to think, should I do 5 10 deposits or 1 100 deposit and add another 50 Ether? If you have that